Hello everyone, my name is Jatin Singh and I am going to present on the topic resistance temperature detectors or RTD. In this PPT, we'll see the introduction, the construction which include the types of RTDs and its signal conditioning units, its advantages, disadvantages and conclusion with in the references of the PPT. In introduction, what is RTD? RTD is resistance temperature detector. It is an electronic device which is used to determine the temperature by measuring the resistance of an electrical wire. We know the resistance increased with increase in temperature, and the mathematical expression is also given in the further slides. Now, why there is a need to measure temperature? We know in various industrial and manufacturing processes and energy production processes, there are various chemical and physical processes going on which need monitoring temperature, as the process may not happen and may be hazardous when the temperature range is when the temperature is out of range of the process that is going to happen. Also, the resistance on a particular temperature can be used to determine the purity of the material. If we need to measure temperature with higher accuracy, RTD is the ideal choice as it has good linear characteristic and wide range of temperature, and it is widely compatible with various types of instruments. Now, the temperature dependence of resistance is given by the equation RT is equal to R naught 1 plus alpha T minus T naught plus beta T minus T naught whole square, and the further higher order terms. Now, if we need to measure temperature of a small over a small range, we can reduce our equation by ignoring the higher order terms and get the equation RT is equal to R naught 1 plus alpha T minus T naught. Now, if we compare the graph of R by R naught versus the temperature, in the x-axis here it is the temperature, we can see the platinum is linear. It is from minus 200 degrees Celsius to approximately 800 degrees Celsius, and it provides a linear response. So platinum is the best choice to have an RTD. And other metals are also used, such as copper and nickel, which have a less range, but when compared to the cost of the platinum, it is quite cheaper. So they can also be used when the temperature range is not exceeding 200 degrees Celsius. Now, about the construction of the RTD, there are two types of design found. First is wire wound design, where the platinum wire is wound around the ceramic or non-conducting material, which provides the structural strength to bear more mechanical stress and vibrations. And the other type is thin film design, where the wire is placed on a sheet and covered by glass or epoxy from one side and ceramic from the other side. The ceramic has to be used to increase the structural strength, as it is not mechanically sturdy material, as wire may break or get damaged when exposed to mechanical stress or vibrations. Also, the RTD is placed inside the temperature environment, changing environment, so the insulation is also required. Now, about the signal conditioning unit for RTs, as we need only to measure the change in resistance or the resistance at a given temperature of the wire, the Wheatstone bridge is the ideal choice for measuring it. We can place our RTD inside the environment where we need to measure the temperature and connect by wires to the Wheatstone bridge where we can monitor the change in resistance. Here, there is one limitation, as the resistance of the wires can also hinder the resistance of the RTD. So we need to use equal length wires and also consider the resistance of the wires when calculating the temperature. Following are some advantages of RTDs. It is highly accurate. Its accuracy level is from plus minus 1 degree Celsius, but in the linear range of the metal used. Its wide temperature range, as we have seen, the platinum can measure temperature from minus 200 degrees Celsius to over 800 degrees Celsius, but the other metals have not this much range. Its stability, the resistance value remain constant over longer period of time, which provides our instruments a longer life cycle. Its linear response, also seen in the graph, the platinum have linear response from this temperature range, so it provides a good linear response and wide compatibility. It's it is highly compatible with other instruments and control equipments. Now, include about the limitation of the RTs, it is highly expensive when compared to other temperature measuring devices because the type of material used, such as platinum, is costlier, and also the design adds to its cost because it need to be insulated, and non-conducting strong material need to be there in the design. Its slow response time, that change in the resistance of the material is quite low when compared to change in temperature. So we need to wait and check the temperature. Other instruments provide the faster response when compared to RTDs. It is fragile as when it is damaged when exposed to mechanical stress or vibration. Though adding ceramic reduces the damage, but it is not as strong as other devices. Its temperature range is high when platinum is used, but normally platinum is costly, so other metals can be used. But when compared to thermocouple, its range is 31 degree Fahrenheit. Also, the self-heating effect of the RTDs is a limitation, as we need to we need to detect the temperature of the environment. But when current is passed to a conductor, its temperature increases, so it calculates it desired temperature change plus its own self-heating effect. This can be reduced by limiting the input current in the RTD to 1 milliampere. I will conclude by saying that RTDs are highly accurate in wide temperature range and wide compatibility, so they are the ideal choice for temperature change. They are based on the principle that the resistance of a metal increase with increasing temperature. It also have some limitations such as cost, slow response time, self-heating, and fragility. But RTDs are excellent choice when highly accuracy and stability and long life cycle is required, such as in space shuttles and rockets. By understanding the advantages and limitation, we can choose the RTD of our choice based on the construction and use it in the mechanical device or any other instrument. Here are some references from which I have collected the data for studying data and pictures for this PPT. Thanks for watching.